In this video, we're going to look at dividing rational expressions. Here's an example. One rational expression divided by another. Now remember, rational expressions are algebraic fractions and follow the same kinds of rules. To divide by a fraction, you flip the fraction after the division sign upside down and change the division to multiplication. To give a simpler example, if you were going to divide 1/3 by 1/2, you would change the division sign to multiplication, flip the fraction after the division sign upside down, so that would become 1/3 times 2/1, and multiply across, giving you 2/3. We're going to do the same kind of thing with rational expressions. We're going to flip the expression after the division sign and change it to multiplication. Also, we're going to find that there are three places we need to look for restrictions. We need to look in the denominator of the first rational expression and in both the numerator and the denominator of the second rational expression, and you'll see why in a moment. None of these can equal 0. So that's a little bit different from what we saw when we multiplied rational expressions, when we were only looking in the denominators to find our restrictions. Now we need to look in the numerator and the denominator of the rational expression after the division sign. So let's do an example. Here's that same example again. First thing we're going to do is we're going to factor. The numerator of the first rational expression is going to factor to x plus 2 times x plus 3, and we can't factor to the denominator anymore. The numerator of the second also we can't factor, but the denominator can be factored to x plus 5, x minus 5, because it was a difference of squares. Now we're factored. Now we're going to flip and multiply. So we just rewrite the first rational expression as is, change the division to multiplication, and now flip the second one upside down. Now we can do our canceling. Remember that if it makes it easier for you, you can put brackets around these to remind yourself that they're fully factored and available for canceling. So this x plus 3 cancels with that x plus 3, leaving 1 in both places, and this x plus 5 cancels with that x plus 5. So what we're left with is x plus 2 times x minus 5. And if we wanted to expand and simplify that, we would get x squared minus 3x minus 10. So that would be our simplified version of this. Now we need to look for our restrictions. Let's come back to the fully factored but uncancelled step. Notice that x plus 5 can't be equal to 0, otherwise we'd be dividing by 0 over here. So in terms of the restrictions, well, when would that happen? X plus 5 would be equal to 0. Solving for x, we get that that would happen when x is equal to negative 5. So we're going to have to rule that out. We make our restriction saying x cannot be equal to negative 5. Over here, this is the same. If this were equal to 0, well, we've already taken care of that. But this is different. So we can't let x minus 5 be equal to 0 either. That's going to occur when x is equal to positive 5. Therefore, we rule out x being positive 5. So now we've covered this denominator and both parts of this denominator. However, also notice that if x plus 3 were equal to 0, then we'd have 0 divided by whatever was down here. This whole rational expression would be equal to 0. And because there's a division sign here, we'd now be, again, dividing by 0. So because of that, this numerator can't be equal to 0 either. When would that happen? Well, that would happen when x plus 3 is equal to 0. In other words, solving for x, when x is equal to negative 3. Therefore, we have to rule that out as well, so we place the restriction that x cannot be equal to negative 3. So when dividing rational expressions, we flip the rational expression after the division sign upside down. We're going to multiply. We're factoring and canceling similar to what we did with multiplication, but we're also going to need to look in one more place for our restrictions, that place being the numerator of the rational expression after the division sign.